Hello, everyone, and thanks for listening to this webinar on how to build application patterns using AWS Cloud Development Kit, or CDK. My name is Ryan Bachman, and I am a DevOps Specialist Solutions Architect with AWS, and I am fortunate today to be joined by Chris. Chris, would you care to introduce yourself?
Yes, I'm Chris. I'm a software development manager at AWS. My current focus is infrastructure as code, and I'm supporting the CDK team.
Great, thanks, Chris. So let's get into it today. This is what we will be talking about today. I'm going to start off by discussing how infrastructure is evolving. This evolution presents certain challenges for organizations, and we will discuss a few of those. We will get into the solution to these challenges by discussing CDK. And I'll also spend some time discussing how an AWS customer leveraged CDK to accelerate their application innovation. And then finally, I will, at the end, end with a quick demo of CDK and show how you can build your own constructs. So I actually like to start this topic off with one of my favorite quotes related to development. So earlier in my career, I spent a lot of time writing infrastructure as code templates. And it wasn't just CloudFormation. I have many hours logged writing Terraform, Ansible, CF Engine. And as I progressed through my career and I switched teams or even switched companies, I would often rewrite these same templates over and over. The number of times I wrote some form of IEC for an auto-scaled EC2 instance, for example, is likely to be in the hundreds. Looking back, though, all those templates had a similar feel and shape. A well-architected VPC is going to look similar across most organizations. Similarly, modern applications that use containers or serverless all tend to use similar patterns. So why is it that we continue to define these patterns in the various IEC frameworks from the ground up? So my hope here is that listeners of this webinar take away some of the concepts that Chris and I will be discussing, and we will equip them with the knowledge to go back to their organizations and hopefully write less code. So why is infrastructure as code so important? Listeners are likely somewhere along the spectrum. On the left, we have our traditional on-premises infrastructure. There are frameworks and utilities here to help automate certain tasks, but it's likely that customers that are in this stage still have many manual processes related to infrastructure. In the middle, you're starting to get your feet wet with IAC. You're likely using some form of infrastructure as code, but infrastructure is still viewed outside the context of an application. Organizations in this stage likely have a DevOps or CloudOps team that owns both the definition and operation of many of the company's cloud infrastructure. And then finally, on the right, you start seeing the lines between application and infrastructure blur. Cloud services are integral to the delivery of modern applications. So in this stage, application developers need the ability to define, configure, and integrate with the services and cloud resources specific to their use case. Tools like CDK unlock this capability and help enable organizations to define complex solutions through abstractions. And this evolution of not only infrastructure, but how you should think about infrastructure in context of modern application creates a skills gap for many organizations. It's been said and also restated over the last 20 years that every business is a software business. And that statement is more true now than ever before. There's an ever increasing demand for digital innovation, but as you navigate down the funnel from general developers to specialized experts, the available supply of these skills are increasingly difficult to obtain. This fact creates a bottleneck of innovation. As an example, companies are looking for ways to leverage AI/ML to extract greater value from existing data. How do companies get started with AI/ML services without really having the specialized resource on hand? But this webinar is ultimately about infrastructure as code. And so I want to talk specifically about some of the challenges customers face with defining infrastructure and services using these common frameworks. So it's time consuming to figure out the best practice for every single service and resource that you need to create. With the pace of innovation at AWS, where we are constantly announcing new services and updating existing ones, who really has time to understand all the details needed to use these services? So I have my own personal journey with the next two challenges. Whether your workloads share common elements or defining full application environments starts to feel like you're recreating the wheel. Failure to apply dry principles, that is, don't repeat yourself, takes away from what really matters for your customers and your business.
And Ryan, in talking to customers, Where do you see them most struggle when it relates to infrastructure as code?
Yeah, Chris, good question. So I talk to many AWS customers and try to help them with challenges that I just mentioned before. One of the most common themes that I see in these conversations is really participation in infrastructure as code. And what I mean by this is it's often the centralized or single platform team that's going to create and own all those infrastructure as code modules. And in larger and even mid-sized companies, this platform team might support dozens, if not hundreds, of services. So the demand on these types of teams in terms of writing infrastructure as code or even customization within existing templates becomes a huge burden for large organizations. These customers are often willing and even hoping that their developers will contribute back to these templates. And while some customers find success, the majority of the customers that I speak with really struggle with this aspect. So my hypothesis here is developers don't like many of the IAC tools out in the market today. Right? They don't feel natural and then are often lacking some of the paradigms that are common in programming languages. But in fact, I was talking to a customer just last week on an unrelated topic, but he flat out told me that he hates writing in YAML. He loves CDK strictly for the fact that he doesn't have to write in YAML. And I think this perception is true a lot with developers, and there's a general reluctance to adopt or even contribute to tools that use strict structured DSLs. And that's actually a good segue into CDK and how it might be different from the tools that listeners to today's webinar might be used to. So, what is exactly AWS CDK? So, AWS CDK is a multi language software development framework for modeling cloud infrastructure as reusable components. But what do I actually mean by when I say that? CDK is multi language, and you can see on the slide the variety of languages that we support. So if you are a Python developer or prefer Go or C Sharp, the CDK framework will provide a consistent experience regardless of which language you choose to use. I also want to emphasize the software development framework. CDK helps bring application and IC code together. In fact, in using CDK, it's general best practice to manage not only the application code, but infrastructure at CI/CD and even configuration all under a single Git repo. In addition, by using the CDK framework, you get capabilities in your IDE that you rely on to develop efficiently. So features such as type hinting or auto completion makes writing CDK code easier for developers. And then beyond the app dev aspect, CDK helps us model our cloud infrastructure. So we do this by using CDK's hierarchical nature. At the top is a CDK app, which is going to represent a particular service or workload being managed by CDK. Just under the CDK app is a CDK stack, which is a class that represents a CloudFormation stack. CDK is ultimately deployed using CloudFormation provisioning, and so the CDK maps the stack construct to be the equivalent of a CloudFormation stack. And then any resources nested under the scope of a stack object will be grouped together in a single CloudFormation stack. And then finally, within a stack, you're going to declare your infrastructure resources using constructs. And then finally, these reusable components. So these reusable components are comprised of constructs. Constructs extracts away much of the complexity in defining and wiring together multiple resources. And they also include sane defaults that can be used for many production use cases. So let's go ahead and dig a little bit deeper into what I mean by a CDK construct. So L1 constructs are automatically generated from CloudFormation resource specification. These are going to be one-to-one mappings between classes and CloudFormation resources. So technically, these don't provide abstractions, and using these classes require a developer to know the properties and the shape of any given CloudFormation resource. However, because AWS can auto-generate these constructs off the resource model, when we launch new services and features within CloudFormation, you get day one support with CDK. Three, two, one. L2 constructs are the higher level service constructs that represent resources scoped to a single service, such as S3 bucket or a VPC. These constructs are simpler and require very little input to generate complex cloud formation templates. These can have many defaults and opinion. And then finally, we have our L3 constructs, which are opinionated abstractions that bring together multiple services to deliver a fully integrated solution or use case. So AWS CDK includes the AWS construct library, which contains constructs covering many different resources across many different services. These libraries offer a starting point to create resources such as networking, ECS and EKS clusters, and databases. I have been hammering on this construct and abstraction layer throughout this talk because this is one of the main advantages of CDK. The power and time savings built into these constructs allow you to compose your infrastructure the way you need without worrying about much of the complexities involved. So let's look at a few examples of what constructs look like. So first level, level one are a low level construct. These provide kind of strict control of what actually gets created via CDK, but also requires knowledge about the properties of the resource specification. You can tell if a class is an L1 construct by the name of the class. So L1 constructs begin with the string CFN to help you distinguish between what are L1 versus higher level constructs. Which brings us to L2 constructs. L2 constructs are handwritten by AWS and can generate a more complex structure and can contain multiple resources, but they are still generally scoped to a specific service. For an example, the VPC example shown on the slide. And I like to show this particular example because this is actually the construct in CDK that actually converted me away from other frameworks. This is only one line of code in CDK. It's extremely simple to declare, but powerful in what it produces. With just this one line of code, you get a well-architected multi-AZ architecture with public and private labeled subnets with NAT and internet gateways attached. So if I had to write this in CloudFormation, and I've had to in the past, that is several hundred lines of code to achieve the same outcome. And if the default is not exactly what you need in L2 construct, whether that be VPC or other constructs, you can include optional properties or override existing behaviors according to your needs. And then finally, that brings us to L3 constructs. L3 constructs are a composition of resources across different services. So here I show an example from a popular ECS patterns L3 construct library. This library helps define all the resources needed to create and host working applications on Amazon's Elastic Container Service. I'm not going to read all of the services and settings that these few lines of CDK code ultimately produces, but just by the diagram itself, you start to get a sense of the complexity that these higher level constructs abstract away for users of the CDK framework. And many of these constructs are maintained by the service teams themselves or SMEs that have the deep knowledge to understand AWS best practices. So in a way, these CDK constructs represent reference architectures codified into simple to use programming classes. So going a little bit further into our constructs, L2 and L3 constructs also contain functions. These functions make it easy to connect multiple services to help enable optional service features. These functions are often used to apply least privilege principles to your CDK app. It also helps simplify the process of defining your permissions. As an example here, we are using the DynamoDB construct and we're using the grant read data function on the table. This function helps abstract away the complexity of writing an IAM policy document by generating all the actions and resources needed to permit access to just a single table. And one of the common use cases that we also see CDK used for is applying governance and compliance conventions across a wide range of AWS resources. So CDK aspects makes this task simple by providing a mechanism to apply standards across all resources under a specific scope in CDK. So a common scenario is a need to apply a tag standard or convention to your infrastructure resources. But managing this standard at a per resource level in something like CloudFormation becomes cumbersome. Aspects allow you to define a set of tags that will be applied to all resources, which is a single line of code.
Now, Ryan, you discussed various levels of CDK constructs. Do you have any recommendations for customers looking to develop their own? Where should they start? L2s, L3s?
Yeah, great question, Chris. So when I talk to customers, I really recommend customers to focus their efforts first on the L2 construct level. Composability is really important in terms of building applications. And so these constructs at the L2 level are really consisting of a single service. So what this allows customers to do is compose their applications with various components at the L2 level. This also gives their developers the freedom to design applications in a way that makes most sense for their use case. The reality is, the more opinions that you start building into are these constructs, the less reusable that these constructs become. So I tell organizations, if you're getting started with CDK and building construct libraries, focus on the common services that you use at the L2 level. But then once you have sufficient coverage at L2, I also often encourage customers to start thinking about how they can compose their L2 constructs into a prescriptive reference architecture at the L3 level. Here organizations should be leveraging their cloud architects to define these patterns and then codify them into CDK to help enable application teams the ability to quickly produce these architectures. And that is exactly the approach that we're going to be talking about here from United. So United kind of took that same approach when building out their construct library. AWS was privileged to have United on stage with us at AWS reInvent, telling their story. So I'd like to take a few minutes to highlight, some of the key points from that presentation. So just to share a few numbers related to United's cloud migration into AWS. So as part of their migration, they've been identifying services to modernize, and they needed help accelerating both the migration and modernization of workloads moving out of their data centers and into AWS. The United Airlines started their CDK journey in early 2022. I believe it was early February of last year that AWS was asked to deliver a CDK workshop to a group of development teams to help generate excitement. By that point, there were a few developers on the platform team over there that knew about CDK and were interested in adopting the framework, but needed help educating and convincing others. Since then, the CDK program has really taken off, pun intended there. They now have dozens of in-house built L2 and L3 constructs and have a thriving internal community that helps contribute to the development, maintenance, and education of the CDK use. So in under a year, a small platform team put in place the groundwork that will help accelerate United Airlines digital innovation for years to come. So let's take a practical look at some of the details on what has made United's journey so successful. So we mentioned previously, I typically tell customers to focus on their L2 construct development, which they did, and they focused on the services that United used most. So United Cloud applications, and this is an example, frequently rely on DynamoDB for data persistence. So it made sense for them to develop an L2 construct for developers to manage, set up a table. But encapsulated in their extended version of this table construct are the standards for encryption and tags. So remember, CDK is a utility that can help enable and enforce governance, and so that's what United did here. United also makes it easy for data service discovery by exporting the auto-generated names that CDK produces to parameter store, which allows other service teams to look up names and connections to those tables easier for developers. So moving one level up in the abstraction layer, United also relies on ECS to host many of their workloads. One of the challenges that United faced when connecting their services to VPCs, they were completely managed by separate networking teams. Services are required to be mapped to specific VPCs and subnets based on service context. So United implemented a system where lookups within the constructs allow service teams to easily deploy ECS applications without having to determine or hard code VPC values into their IAC templates. This example of extending and building upon Amazon's provided constructs allows United app teams to operate more autonomously and innovate faster. United also uses CDK in their cost optimization efforts. Here you can see a simple conditional that determines if spot instances are used based on the environment. If it's dev, they're going to switch on Fargate Spot, but any other environment, they'll just leave it Fargate. And this simple addition has led to significant development cost savings for United. United also takes use of aspects. Remember, I talked about aspects in terms of tagging previously, but United uses this feature to apply permission boundaries within their application. So, permission boundaries are an advanced feature of IAM to implement guardrails on the set of permissions allowed for IAM users and roles. So, United uses this capability in CDK to apply permission boundaries to roles created within United CDK apps. And this way, application teams don't necessarily need to know their boundaries. They are automatically applied for them when they create their applications. So they essentially get compliance for free. United developers like the versioning capabilities of the construct library. So versions allow them to track changes over time and provide clear indication when new features are available or bug fixes have been implemented. So United also auto generates API documentation for their construct library. This helps with their self-service mission and makes it easy for new teams to adopt CDK. To understand the usage of new and existing United constructs, United hosts the auto-generated construct docs for developers to consume. Their documentation effort alone has helped reduce the number of tickets on the platform team and helped with the overall CDK adoption. United developers are getting used to the self-service way of operating, and this has freed up the platform team to work on higher priority projects. And then it gets more fun for United. United takes advantage of the JSII, which helps them produce their internal construct libraries in all the major languages that their application teams use. So you have this example in the native TypeScript implementation for a construct, but that construct is the same as this one that is written in Python, and they also use Java, so they also have an available construct available to them in Java. So let's take a look at the benefits United realized from adopting CDK. First, they have simplified the process of tagging resources, which helps United track cost usage and other operational dimensions of the resources. Constructs help United app teams remain secure by transparently applying permission boundaries for their application and enforcing governance controls. They also codified what was manual processes in the past into instrumentation in their L3 constructs that allows service teams to quickly deploy United reference architectures using container services on AWS. This has helped accelerate application teams to develop and deliver new services faster than before.
Ryan, love the wins. What lessons did you learn or challenges did you hit?
Yeah, so initially, United was very reluctant to use JSII and produce all the polyglot languages that CDK supports. There was some complexity. They weren't comfortable as a new tool, and so there was initial reluctance. And when they rolled out the first version of CDK, they didn't realize the adoption rate that they had hoped. And the lessons learned was right at the end of the day, CDK is trying to meet the developer teams where they are. And part of meeting the developer teams where they are is meeting them in the language of choice. And so United took a step back and realized that that was an important feature and capability of CDK to easily produce these polyglot um, libraries for their entire application teams to consume. So that was one challenge and lesson learned. The other, I think, lesson learned in this is each organization, I think, is going to have its own personality when it comes to CDK and CDK construct libraries. There's some general best practices when writing constructs, and we provide some of that guidance. But United was reluctant to take ownership of their own CDK construct library and really make it their own and find their own convention and paradigms and what works for them. So I think that as organizations look to move and follow United's journey, it's okay to take liberties. This is a development framework just like any other development framework, and so What I encourage customers is adhere to the best practices, but also don't be scared of injecting your own personality or your own idioms into when you develop your own construct library. I think that really helps go a long way in evolving and building that internal community. And then beyond the wins, I just want to call out a couple additional benefits. These aren't traditional wins from a United perspective, but these are more benefits that United realized, but didn't really expect going into the project. So they aren't hard coding values in IAC anymore. They're taking advantage of the CDK lookups capabilities to dynamically fetch the context that's needed. They implemented cost savings with CDK via easy to implement conditionals. CDK versioning gives them change management, which I actually show an example of during an upcoming demo. And then finally, they scaled their platform team by really focusing on enabling self service through documentation. And now it's time for the demo. So today I'm going to be demoing from a new service called Amazon Code Catalyst. So Code Catalyst was announced during reInvent last year. And I just want to provide some background because I'm going to be showing the demo in context of Code Catalyst. Code Catalyst is an integrated development platform that aims to make it easier for developers to manage the entire software development lifecycle by providing a unified experience across the SDLC to include project management, manage Git, CI/CD workflows, and consistent developer environments. So here you can see on my screen that I have two projects created for the demo. One project will be where I create a CDK construct, and the other will be used to consume and build an application from that construct. So the first thing I'm going to do is go into my construct library. Here, I just want to show you within my project, I have a Git repo, and this is where I'm going to host all my construct code. Traditionally, as you start to build out a construct library, um, traditionally you'll find these to be mono repo, and you'll have tools such as like Lerna and Yarn to manage the mono repo. But for our use case, it's going to be simple. We're just going to create one construct today. In order to author my code, Code Catalyst provides dev environments. These are on-demand, container-based development environments that I can spin up and begin coding in seconds. You can see here that I already have a development environment running, so I'm just going to go ahead and switch into that and then clean up my screen a little bit. So the first thing I want to do when I start building a construct is I'm going to scaffold that code by using the CLI tool. So the CDK comes with a CLI tool, and the CLI tool not only is it used for kind of workflow management and deploying CDK applications, but it also helps you set up projects with a single line of code. So for us, we need to go ahead and create a new directory first. So call this example construct. And then I am going to use the CDK command line tool to go ahead and scaffold the code that I need for my construct. Now, the CDK can scaffold both constructs and libraries, but when you're building constructs, you have to write in TypeScript because because the JSI works on the TypeScript code and allows you to cross compile into the various other supported languages. So once the CLI command completes and all my dependencies are installed, I can expand my view here, and you can see that within my directory, I now have boilerplate code that's going to allow me to get started writing my construct quickly. I don't want to make this demo a coding exercise, so I do have a start of a construct on a different branch. Let me just go switch into the branch with that code. And here you can see I have a directory called serverless REST service. I can go ahead and open the construct file. and you can see what is the start of a L3 construct. So the use case that I'm building towards today is, imagine I'm an organization and we build microservices and we've standardized on REST microservices. So if you're building or serverless REST microservices. So if you're building serverless REST microservices on AWS, traditionally you have an API gateway that fronts your service, and then the backend is supported by, you know, different compute runtimes. In this case, this is a serverless REST service. So we are going to be backing the API gateway with a Lambda function. So I want to make that easy for my service teams to adopt that architecture and quickly produce services that operate in that same fashion. So the first thing I'm going to do is I'm going to clear these errors away. These are generating because I don't have my dependencies installed. So I'll go ahead and install my dependencies. And while that's installing, I'll just quickly walk through what we have so far. So the first part is I have a properties interface, and this allows me to define and declare which properties to my construct are either optional or required. And then starting on line 12, we have our actual L3 construct. We're going to extend the base class construct, and then we are going to use various L1, L2 constructs to compose our L3 construct. Here you see we only have two L2 constructs that are currently declared because this is a serverless API um, microservice, REST microservice. We need a Lambda function and we need an API gateway. And so here, all we're doing is we're allowing the consumers of this construct to pass in properties to the Lambda, which will allow them to define the source code of that Lambda, the runtime of that Lambda, as well as the handler. But we're going to handle in our construct wiring these two services together. So extremely simple use case. But remember from my presentation, I also said L2, L3 constructs are also a great way to enable and enforce standards. And so we want to do the same thing here. So as an organization, we have some tagging standards, and we want to make sure that we're applying those tags across our constructs. And so our standard here is we want to make sure that we include a service name in all our resources. And this will allow our operations team, our finance team, the ability to audit cost allocation or other operational dimension needs of our resources. So we're going to go ahead and add a new property, and we're just going to call it service name. And then finally, when we want to go ahead and apply those tags, we're going to use the tags aspects. And so that's a simple command that we can add in one line. And we're going to call this tag service name, and we are going to take the value from our properties interface. The other thing I actually like to do when I build constructs, and I kind of encourage customers to do this, is also create a tag of the version package name and version, which allows you, as you start deploying resources using your constructs, this gives you the ability to monitor which of your constructs are being used and at what versions. And this kind of benefits you in a couple different ways, right? So if you can kind of measure which constructs your organization uses, it's going to allow you to prioritize development of those constructs further, or focus on maybe complementary constructs of services that typically surround that particular construct. And then similarly, if you find certain constructs not being used, it helps you prioritize or deprioritize development of those constructs, or even kind of decommissioning or deprecating those constructs. And then the versioning allows you to kind of audit your environment for best practices. So here we're building essentially version one of this construct. Imagine that we create a new version later with maybe changes to the best practices. Now, by looking at that tag value of what version is deployed, you can now get an overall sense of the overall health of your ecosystem by seeing which constructs are still deployed in your environment. So to get that information, it's fairly easy to do. We're just going to import both the name and version field from our package file. And now as we version our package, we'll have a good way to audit that after they're deployed. And then like before, let's go ahead and apply that tag. We'll call this CDK construct. And we'll give it a value of name actually. Name. All right, so just to recap what we did here, we had some starter code, but what we did was we created an L3 construct that wired together both a Lambda function and an API gateway, and then we used an aspects of tags to apply our tagging standards across all resources, whether they're declared here or resources are abstracted and are being created by using these L2 constructs. So now all we have to do is build and publish this library so our service teams can consume it. Because I am in Code Catalyst, I actually have a pipeline that will automate that process for me. So all I have to do here, and I think I have a version conflict. So the first thing I'm going to do is I am going to bump my version, and then I am going to commit and push my code. And now I'm going to navigate back into Code Catalyst. And this time I'm going to look at the CI/CD workflows. Um, and I had this prepared and built beforehand, but this just shows you can create a CI/CD pipeline related to your construct library. So as you make changes, you can automatically test, build, and publish those into some kind of code artifact store. So if I go into the branch that I'm operating on, you can see here that I have a CI/CD running. And not that it's interesting here, but like you'll see here the various steps that this will take to run my build, to run my package, and then to eventually upload that into a code artifact repository. But in the meantime, while this is building and publishing, I am going to switch over to my application project. So this is a new dev environment. This is in a completely different project, completely different development environment. And what we are going to do here is we are now going to create an application based on the L3 construct that we created previously. So much like before, we're going to use the CDK CLI tool to help enable that. The first thing we need to do is create a directory like we did before. So we're going to create a directory and we're just going to call it my app. We'll go into my app and then we'll use the CDK command that we did before. But this time, instead of doing a library, we're going to do an application. And then the language, just to show the power of CDK, instead of doing TypeScript, because we wrote our construct in TypeScript, we're going to switch the language and we're going to run a Python application. And much like before, this is going to do all the scaffolding specific to the language that I choose, right? So if I had chose, Go or another language, the scaffolding would have created the required file specific to that language. Here, if I expand my app, you can see some Python specific files that were boilerplate to help me get started. Um, the application itself is going to be defined in a stack. And the stack is where we're going to declare all my resources. And this is where I'm going to instantiate a um, uh, basically an instance of the CDK construct that I created previously. So let me get rid of some of this boilerplate code. So the first thing I need to do here is I need to ensure I have the right imports. So I remember I read the documentation. I understand the API of this new serverless REST service construct, and I realize I need a Lambda runtime. So I'm just going to import that library. And then I also need to import the construct library that I published to Code Artifacts. So to do that, I first need to install this. If this was a real project, I would likely put this in my requirements file and install it this way. But just because it's a single library, I'm just going to install it via pip. And we called it serverless REST. So I'm going to install our construct via pip. And you can see here the version number 02 matches the same version that we built via our CI/CD process. So once this is done installing, I can go back into my stack and import it into my application. Called serverless REST service. And I am going to import the class. So now all I have to do to create an application using this construct is just instantiate it. So I will create a new but remember we have those required properties that are expected when I declare this construct. And because I have API documentation, I know what those are, as well as IDs will also provide kind of that type hinting to allow you to understand the API for this particular construct. But since I know what those are, I am going to declare those now. So service name, that service name for the tag convention, and I'll just call this webinar. We had the Lambda runtime, so we can supply the runtime. Again, AWS Lambda runtime. We'll make it Python 3.8. Add the handler, which is essentially the file and function entry point into Lambda. So we'll call this app.handler, which is pretty standard. And then we have our handler source. And handler source is where are we going to supply the code that is going to run the Lambda. In this case, we'll create a folder called Lambda. And we'll save that. So now the only thing we have to do is go ahead and write our Lambda code. So we'll go back up into our directory. Now we said the handler, oh, sorry, I've got the actually handler source for this property. So the handler source is going to be Lambda. So we'll go back and we'll create a new folder and we'll call it the same. We'll call it Lambda. Then inside our Lambda folder, we can create, to match our handler, we'll create this as app.py, and then we'll have a function within our handler or within our file called handler. And then we just have some boilerplate Lambda code. And then because there's an API gateway in front of this, we know we have to return what the gateway expects. So we'll return the status code of 200 and a message. Hello from the CDK. And that's it. All we did with a few lines of code using a construct that was built for us, we can now deploy our application just with 5 or 6 lines of code, and everything is going to be tagged according to our organization's convention. So let's go ahead and test it out. So if I do a CDK, deploy, so to test the application deployment to see if we can build our application based on the construct that we produced, we'll just go ahead and run a CDK. And this is just notifying me that it's going to create some IAM permissions and some additional AWS resources, and then we'll just take about a minute to fully deploy my application. But while it's deploying, and we'll come back to the result of that application here in just a second, I want to talk a little bit about the change management aspect of CDK constructs. I mentioned this in the presentation, where versioning your construct library gives you the ability to do change management. So the the example here that I like to use is, so we have our version one of what a serverless REST service looks like at our organization. But as it's written now, there's no authentication, there's no authorization, there's no restriction on who can use our REST service. And let's say these services are to be consumed internally, and we want to have some kind of um, authentication mechanism to protect our services. And so we can update what the best practice of this construct is by adding some additional configuration into our original construct. So the first thing we want to do here is enable API keys. So we're going to use API keys as the way we're going to authenticate our application. And so we are going to use the default method options, and then we are going to set the API key option to be true. So we have a property called API key required. We'll go ahead and select that, and then we'll just enable that to be true. But now we also need to supply our API keys. And this starts to provide examples of how L3 constructs can be valuable to organizations. Um, the complexity of, like, how do you actually enable API keys? Service teams may not necessarily understand, or understand how to configure and wire those up. So here, as an architectural group or as an SME on these services, I can now write these constructs, and my service teams don't necessarily need to know how that all works. So the first thing I'm going to need to do is I actually going to have to use this gateway. So I am going to provide it a variable, and then I am going to create a key by using a function of the gateway. I forget. And we're going to use the add API key, and we're going to give it a name. But in order to use API keys, we also need a plan, called a usage plan. So we can add one of those as well. And plan. Next thing we need to do is add the key to the plan. So we can do that. And then the final thing we need to do is we need to add um, the plan to the gateway. So We added a few just to review what we did here. So we added a default method or a default option that requires API keys. We're going to go ahead and add a API key to our gateway, and then we're going to wire that API gateway or wire that key up so it can be used. The last thing I want to do in this construct is to provide a helpful message as an output, which allows the service teams to understand where they can fetch the key value. We don't want to output it onto the screen, so we're going to make our service teams fetch that value once it gets created. So to do that, we're just going to use the CFN output class. And this will output display a message on the screen. Sorry, it's difficult for me to code when I'm switching between TypeScript and Python. I forget what I have to declare and what I. And we'll set the value. And we're just going to have a nice friendly string here that says. We have a nice friendly message that will display when the next time the service team updates their CDK application. Let's go back into our app. So now you can see that our application was deployed. We have a URL. So before we update the service, let's go ahead and verify the behavior. So the first thing we'll do is we'll curl this endpoint. This is a REST application, and we should get our return message back. So you can see here on the output that we got our hello from the CDK webinar back, and this matches our code that we wrote in our application. So that all works. The other thing that I want to show from this demo is remember we used tags for the assets. So let's go ahead and look at our API gateway source. And we'll look at the gateway that it produced. And the thing I want to show you here is remember we had our tagging convention that was applied. So just to verify that indeed all our resources were tagged according to our convention, we could go ahead and look at the various values of the tags. And you can see the two tag aspects that we created, both the service name and the CDK construct with the package name and values are here. So all that works. So now in terms of change management, now I want to adopt the new version of my code. So the first thing I need to do is go back and make sure that I build and publish a new version. So to do that, I've updated my code, right? I've updated my code with all the additional configuration that we want in our L3 construct. And so all I'm going to do now, and let me clean up some of my environment. I'm going to bump the version again. And this would actually be a breaking change. So this, if I was doing this correctly, I would actually probably want to bump the major version. And then instead of running it through our CI/CD pipeline like we did before, I'm just going to build and publish locally. Let me run the build first. And then I'll package into Python. And then finally, I'm going to upload it into our code artifact store. You can see I published version 5. And so now going back to our application, um, you know, the the architecture team might have updated me and say, "Hey, there's a breaking change. We need everybody to conform to this new standard." And so, as a service team, I would be responsible for updating that library and then applying those changes. So I'm going to go ahead and upgrade my version of the construct. You can see here that I've installed version 5 with replacing version 4. And without making any changes to my code, right? So my code, I don't have to implement any changes. The construct change will apply that change management for me, right? So I can go ahead and just reapply via a CDK deploy. Now, once my application is deployed, you can see the friendly message that we created in the construct to help service teams understand how the change in the service, as well as to where to get the key value. And just like before, we were able to curl this endpoint. If I were to go ahead and curl this now without any changes to my application code, um, we should see a message that says forbidden, right? And if we were to follow through this process, we can go ahead and into the API gateway and look into our API keys. And now you see that we do have an API key, and we can go ahead and use this value to build clients or connect to our API. So that hopefully shows the change management capabilities of versioning your construct libraries. So just to recap, what we did here today. So we started off with nothing, right? We went ahead and initialized, and we scaffold a new um, construct in TypeScript. We had some starter boilerplate, but we went ahead and extended it, and we used tags aspects to tag our resources in convention, as well as wire two L2 constructs together to produce our own L3 construct. We went ahead and deployed that in a CDK application with only a few lines of code. And then finally, we went ahead and made an update to that CDK construct. We added some authentication, some complexity behind that, and allowed us to abstract that complexity away from our downstream Python service teams to implement secure and best practices for our organization. So to close out this presentation, I just want to leave you with some additional resources. Here we provide some additional links. So if you're interested in CDK, we have the product site as well as a public workshop that we'd like customers to run through. The full United CDK presentation at 2000 from 2020, 2022 reInvent is at this YouTube link. It's a great presentation. The principal engineer over there goes a lot deeper into how they built the construct library and the community around that. So I recommend a watch there. And then finally, I know we didn't get deep into Code Catalyst, but if you're a developer and you're interested in developing CDK constructs or CDK apps, please go check out Code Catalyst at codecatalyst.aws to learn a little bit more. That concludes our webinar for today. Thank you for joining and listening to the content. And I hope you go forth and start building your own CDK constructs.
This was awesome, Ryan. Thank you so much.